All right, so we're going to start going into Chapter 8, which is skin disorders. Starting now and going until the end of 274 in the fall, we're going to be talking about individual organ systems and their disorders. So up until now, we've been talking about things like inflammation, infection, healing, pain, pharmacology that apply to all the systems in the body. Now we're going to start getting down to the individual systems and disorders. What goes wrong with that system? So as part of each chapter, we are going to review the normal anatomy and physiology of that area, which should be reviewed from your anatomy and physiology class. And then we will go to talk about individual disorders. So a lot of the things we've talked about, inflammation and infection, we will have one section on cancer and neoplasms, and we talked a little bit about that in the first chapter. We'll talk about skin cancer, and we'll talk about cancers of other systems of the body. So in each of the chapters now, from now on, we're going to review the normal function of that organ system, and then we're going to talk about diseases of that organ system. So functions of the skin. Skin is awesome. It's the largest organ in the body, as well you know. Even though some functional anatomists are starting to talk about fascia as another organ, but we will just get into that later. So the skin really plays a huge role in the function of the body and a lot of other areas. So you know there are a lot of differences in skin, and some of it says in the book like how we're perceived in society. So think about that. Kind of an interesting thing. So unbroken skin acts as our first line of defense. That is our first non-specific line of defense against pathogens that are coming in the body, or trying to, but the skin's going to stop it. So if our skin's unbroken, we're protected against invasion by microorganisms and other foreign material. So we have sebaceous glands, which produce sebum or oil, which is acidic, and it inhibits bacterial growth on our skin. We do have resident flora of our skin, Staphylococcus epidermidis, which is a deterrent for the invading organisms because it takes up space and resources. And so the invading organisms can't get a toehold in it. So skin also helps prevent excessive fluid loss. It's important in controlling body temperature using cutaneous vasodilation, which increases peripheral blood flow, and increased secretion of sweat, which involves evaporation and cools the body. So a huge important part of our skin is the sensory perception of the skin. And we will talk about this so much in neuro, it won't even be funny. We're going to talk about all the mechanoreceptors and everything else, and how important that sensory feedback is for everything. Sensory feedback is important for motion. Sensory feedback is important for balance. A lot of times people, after a neurological event, or neurological injury, the problem is sensory. They can't perceive where they are in space. It's one of the reasons why I like aquatic therapy, treating in the pool. We get a ton of sensory input from the water. Another cool and important function of the skin is that when you expose skin to UV light, it produces vitamin D. Vitamin D is huge. And even though we talk about it as a vitamin, nutritionists are now talking about it as a hormone. There's a huge function of vitamin D in calcium storage, and calcium is super important for muscle function and nerve function, and a lot of other functions in our body. So vitamin D, essential. And hey, isn't that great that our skin does it? Of course, as I mentioned before, if you live in Washington, Western Washington, you're not getting enough vitamin D from the sun, and you need to take a supplement. So maybe this time of year when the sun's out all day, I was just out walking, and man, it was beautiful. All my neighbors were out working in their yards and walking their dogs and everything. And maybe today we got enough vitamin D, but not for the most part, and definitely not in the winter. So just to review normal skin, there are basic layers. So the epidermis is avascular, The dermis contains all the vascular portions of the skin and a lot of the other cool stuff that's involved. And the subcutaneous tissue, which is also known as the hypodermis. And we will talk about each one of those. So the epidermis consists of 5 basic layers. They vary in thickness. One of the interesting things I found when I took anatomy and physiology 30 years ago, and then when I took it again years later, they had renamed the layers of the skin. And now they've kind of gone back to what the original layers are. So I don't necessarily expect you to be able to name those, and unlikely to come up on the board exam. But things about wounds and skin lesions will definitely come up on the board exam. But the basic 5 layers are the base layer, or stratum basale, the spiny layer, or stratum spinosum, the granular layer, or stratum granulosum, the clear layer, or stratum lucidum, and the horny layer, or stratum corneum, and that's the outermost layer. And it's comprised primarily of flat, dead cells that are constantly being shed and replaced from the underlying layers. So the interior of the stratum corneum cells are filled with a dense network of keratin fibers, and that makes them that strong waterproof barrier. So that's why we can take a shower without soaking up a bunch of water, because we have that keratin. Keratin is waterproofing for the skin. So our skin pigment is melanin, and that determines our skin color. And the production of melanin depends on multiple genes and environment. Environment underlined. So this photograph is of my arm and my friend Jen's arm. Jen lives in Hawaii. She is blonde and fair-skinned by nature. I have dark hair, as you well know. I live in Western Washington. She lives in Hawaii. Look at the difference in our skin color. So she has a lot of melanin production because she snorkels and swims and paddles and is a lot of times in the sun. And I have very low melanin production because I have Irish genes and I live in Western Washington. So huge difference. Gene and environment. That's what's going to determine your skin pigmentation. So your melanin production it protects you from environmental factors as well as resulting from environmental factors. So dark-skinned people rarely develop skin cancer, or much less than light-skinned people, because ultraviolet light exposure doesn't activate more melanin in their skin. They already have a lot of melanin in their skin, and it acts as a protection from the sun's rays, which is pretty cool. So when somebody lacks the gene for a melanin production, this is albinism. So that person is considered albino. It's a recessive trait. It's a congenital disorder. So a person who is homozygous for that recessive trait has white skin and white hair, and they lack pigmentation in the iris of their eye. Obviously, this person needs to avoid sun exposure because they don't have any protective mechanisms. Vitiligo is small areas of hypopigmentation that gradually spread to involve larger areas. Melasma is patches of darker skin. Some people get that. They develop them on their face during pregnancy or with some sudden sun exposure. Keratin is a pigment in the skin that gives a yellow cast to the skin, a yellow tone. And pink tones in the skin are increased with additional vascularity or blood flow in the dermis. So the color and texture of your skin has some to do with genetics, some to do with environment. So here's our layers of the epidermis, which we went over. Once we start getting into the deeper layers, we have actively mitotic cells. So in the stratum basale, that's where our cells are dividing and creating new cells. In the stratum spinosum, we also get protein synthesis, and keratin is our protein. In the stratum granulosum, that's where the keratin really starts to form. The stratum lucidium it's the clear layer. And the stratum corneum is the waterproofing barrier. That's where our dead cells are filled with keratin, and they're our body armor. That's pretty cool, right? I think it is. But anyhow, the dermis is connective tissue that is deep to the epidermis. So it's a thick layer, and it varies in thickness over the body. It includes elastin and collagen fibers. So elastin gives it flexibility, and collagen gives it strength. The dermis is super important because it contains nerves and blood vessels. And it includes the sensory receptors for pressure, touch, pain, heat, and cold. And we'll talk about all those nifty little mechanoreceptors a little bit in modalities class, because we want to stimulate those mechanoreceptors with modalities, and a lot in neuro class in the winter. So we have all sorts of nifty appendages embedded in our skin. They're accessory structures, such as hair follicles, sebaceous glands, and sweat glands. So the hair follicles, they are lined with epidermis that's contiguous with the surface. And the stratum basale produces the hair. So each hair follicle also has a smooth muscle attached to it, which is called the erector pili, and it's surrounded by sympathetic nerves. So that's what makes your hair stand on end or gives you goosebumps. Activation of those erector pili muscles, which I think is kind of neat. So if you're cold, boom, the hairs stand up on your end. If you're scared, same thing. So sebaceous glands, they are usually associated with hair follicles, but some of them are not, and they just open directly under the skin. And they produce sebum, which is your skin oil, and it keeps your hair and skin soft, and it hinders loss of fluid from the skin. There are two types of sweat glands, apocrine and eccrine. So the apocrine glands are located all over the body and secrete sweat through pores onto the skin in response to increased heat or emotional stress. So that's your fear sweat, I guess. That's your practical exam sweat, we'll just say. Apocrine sweat glands are located in the axillae, scalp, face, and external genitalia, and the ducts of those glands open onto hair follicles. So the secretion of sweat or perspiration is odorless when it's formed, but bacterial action by our normal skin flora often causes odor to develop with sweat. So underneath the dermis is the subcutaneous tissue, or the hypodermis. And the hypodermis consists of connective tissues, fat cells, macrophages, we know the importance of those guys, fibroblasts for shooting out collagen, and our larger blood vessels. So the smaller ones are in the dermis, and the larger ones are in the hypodermis, and nerves. Got to have nerves. And the base of a lot of the appendages, like the hair follicles, is in the hypodermis, or the subcutaneous tissue. So I talked a little bit earlier about the normal flora of our skin. If you do a swab on your skin and grow it on a culture dish, you will find some nifty little normal flora. Staphylococcus epidermidis mainly, and Staphylococcus aureus. They are our constant companions. They live with us. They live on our skin. The only time they are baddies is when they get where they're not supposed to be. So microbes also reside under our fingernails, in our hair follicles, and in glands. So these guys are opportunistic pathogens, meaning they're not going to cause any trouble normally, but when they get someplace where they're not supposed to be because of injury or inflammatory lesion, they can cause infections. And infections can spread systemically from skin lesions. So it's really important to protect your skin. One thing, working in a healthcare facility, you really notice is you go, oh my gosh, I got a paper cut, I better wash that and cover it up. You really start to become far more aware of the importance of your skin barrier. So a lesion basically is abnormal or disrupted tissue of any organ system. So when we talk about skin lesions, we talk about the physical appearance of the lesion, and that's how they diagnose it. So skin lesions can be caused by systemic disorders like liver disease, as the example they give here, systemic infections like chickenpox or shingles, which is chickenpox's older brother, allergies to ingested food or drugs, or localized factors like exposures to toxins causing contact dermatitis. And we're going to talk about all that nifty stuff. So lesions are classified by their location, the length of time the lesion has been present, the changes in the lesion over time, the physical appearance, color, elevation, texture, and type of exudate, if any, and the presence of pain or pruritus, and pruritus means itching. So some skin lesions can be super painful and some are itchy, allergic responses. They talk about in the text how mechanisms producing pruritus are not totally understood. There's definitely chemical releases, like the histamines in a hypersensitivity response, but they can also result from mild stimulation of pain receptors by irritants. So redness and itchiness are really common. Scratching a pruritic area usually increases the inflammation and may lead to secondary infection. Infection results from breaking the skin barrier and allowing our normal flora, microbes under the nails and in the skin, to invade the area. And then you can get scar tissue, and under certain conditions it can become systemic. You can end up in the hospital. So it's not a good thing. So if something itches, don't necessarily scratch. That's the moral of the story, I guess. So here are some of our common skin lesions, and this is from the figure 8.2 in the text on page 145. A macule is a flat, circumscribed region. A nodule is a firm, raised, deep region. A papule is a small, solid elevation. A pustule is raised, often with a white head filled with exudate or pus. That sounds lovely, right? There was going to come a time when we'd have to start talking about pus. A vesicular blister is a thin wall. It's raised and it's fluid filled. So I think all of us have had that from minor burns. A plaque is slightly elevated, flat, scale-like lesion. So they talk about psoriasis plaques. It's a slightly elevated region. An ulcer is actually a cavity in the tissue, and a fissure is a crack in the tissue. So this is the table from the book that shows just what we went through. So you can go through, and there are some different ones that aren't in the graphic. There are all of the different skin lesions. They are just used diagnostically to identify different conditions.